Welcome to CBS Easy.
Welcome, everyone. If coordinate geometry has been feeling a little tricky, you're in exactly the right place. In this masterclass, we're not just going to look at formulas. Nope, we're going to master the strategies to solve the exact kinds of questions that pop up on your board exams so you can score full marks. So, think about it for a second. How do we describe an exact location? On a map? A screen? Anywhere on a flat surface? Well, it's kind of like a treasure map, right? You need two key pieces of info: how far to go across and how far to go up. That's it. That's all coordinates are. It's a simple but super powerful address system for everything. All right, before we dive into the heavy-hitting formulas, let's get a couple of key vocabulary words locked down. You will see these in your exam, and just knowing what they mean can be an easy one-mark win. They sound a little complicated, but trust me, they're not. Okay, first up, abscissa. It's a big word with a really simple meaning. It is just the fancy name for the x-coordinate. It tells you how far you are from the y-axis, your left-right movement on the graph. That's your abscissa. And, of course, where there's an x, there's gotta be a y. The partner to abscissa is ordinate. And you guessed it, that's just your y-coordinate. It's the up and down movement, your distance from the x-axis. So remember, abscissa is x, ordinate is y. Easy marks, right? Okay, time to grab the most important tool in our entire coordinate geometry toolbox: the distance formula. I'm not kidding. This thing is the workhorse of the entire chapter. You are going to use this for pretty much everything, from finding simple lengths to proving really complex shapes. Let's see how it's built. Now, here's the really cool part. The distance formula, it isn't some brand new scary thing you have to memorize from scratch. It's actually a concept you already know really well. The Pythagorean theorem, just, wearing a clever disguise. If you look at this image, any 2 points can become the hypotenuse of a right-angled triangle. It's really that simple. And here it is. This is the formula. Seriously, pause right now if you need to. Write this down. Say it out loud. The distance is the square root of the change in x squared plus the change in y squared. You need to get this into your long-term memory, like right now. Now look, knowing the formula is one thing, but using it without making those little careless mistakes, that's the real game. And the secret is to be super methodical. Every single time, follow these 3 steps you see here. Label your points, substitute them carefully, and then simplify. This habit alone will save you so many marks. Okay, theory is great and all, but the marks come from solving actual problems. So let's put this formula to work and see how it helps us crack some classic exam questions, starting with everyone's favorite topic, proving quadrilaterals. I can almost guarantee you've seen this question. It's a total favorite for a 3-mark question. They give you 4 coordinates and ask, hey, prove these points form a square. Just sketching it out isn't going to get you the marks. You need a rock-solid mathematical proof. And the distance formula, that's the tool you're going to use. Okay, listen up, because this is where a lot of students lose a mark. To prove something is a square, it is a 2-step process. Step 1, you use the distance formula to show that all 4 sides are equal. But wait, you can't stop there. A rhombus also has 4 equal sides, right? So you need step 2. You also have to prove that the 2 diagonals are equal. That's 6 calculations total. 4 sides, 2 diagonals. You do all that, you've proven it's a square. Let's make this super clear with an example. As you can see in this table, after we use the distance formula 6 times, we get a really clear result. All 4 sides come out to be the square root of 34. That's condition 1. Check. Then, both diagonals come out to be the square root of 68. Condition 2. Check. Once you have that, you just write your conclusion. Since all sides are equal and the diagonals are equal, the given points form a square. Boom! Full marks. Okay, seriously, this is a huge exam alert. This method we just walked through for proving a square, you can adapt it for rectangles, parallelograms, and rhombuses too. This type of question is almost guaranteed to show up on your paper. If you master this method, you're in a fantastic position. Let's switch gears to another classic problem. So imagine 3 friends sitting in a classroom. Just by looking at them, you might think, yeah, they look like they're in a line. But in math, looks like isn't good enough. We need proof. So how can the distance formula tell us for sure if they are perfectly lined up? The word for points that line on the same straight line is collinear. And the test for this is just beautiful. It's so simple. If you have 3 points, let's call them A, B, and C, you find the 3 distances between them. If the two smaller distances add up perfectly to equal the biggest distance, so AB plus BC equals AC, then yes, they are collinear. If they don't add up, you've just made a triangle. It's that easy. And the last keyword for the distance formula is equidistant. It means exactly what it sounds like, equal distance. So when a problem says point P is equidistant from points A and B, it's giving you a direct instruction. It's telling you, set the distance PA equal to the distance PB. This will create an equation you can solve. It's a really common way they set up questions. So far, it's all been about measuring the distance between points. But what if we need to find a point that's on a line segment? For that, we need our second major tool, the section formula. This is what you use when you need to find the coordinates of a point that divides a line in a very specific ratio. Okay, I know. This formula looks like an absolute monster, but don't let it scare you. All it really is a very clever way of finding a weighted average. That ratio, M1 to M2, just tells you how much pull each end of the line has. Your job is to just be very, very careful and substitute all the values into the right spots. Stay organized, and this formula is totally manageable. Now here's a shortcut that will save you a ton of time. This is a big deal. When a question asks you to find the midpoint of a line, that means the ratio is just 1 to 1. And look what happens. That big, scary section formula simplifies down into this beautiful, easy midpoint formula. You just average the x's and average the 1i's. You have to memorize this one. You're going to use it constantly. All right, we've learned the formulas. We've seen how they work. Now let's get super focused on what really matters for your exam. I'm going to give you a checklist of the top 5 question types that you see again and again and again. If you can master these, you are going to walk into that exam feeling so confident. Here it is. This is your final exam checklist. Go through it and be honest with yourself. Can you prove what kind of quadrilateral you have? Can you check if points are collinear? Can you handle those equidistant problems on the x or y axis? Can you use the section formula to find a point? And can you use it backward to find the ratio? If you can confidently say yes to all 5, you are absolutely ready for this chapter. So, as we finish up, just remember this. Coordinate geometry isn't just about memorizing formulas. It's like learning a powerful language. It lets you use the solid logic of algebra to solve the puzzles of shapes and space. Practice the question types we talked about. Really master these tools, and you won't just pass. You'll nail it. Now go solve some problems. You've got this. Good luck.
Thank you for watching with us. See you next time.